All right, this is linear program example 2 from the notes. All right, so now this is going to be slightly different than what we've seen before, but very similar setup. So we're a company that's trying to determine how to allocate its $145,000 advertising budget for a new product. All right, so we can either advertise in newspapers or on television. All right, and so this is what it tells us, is for our first 10 newspaper ads, each ad will reach 900 new customers and will cost $1,000. For 11 to 20 newspaper ads, we'll get $700 per ad and $900 is our cost, and so on and so forth. One thing to note, that this decreasing reach of customers, we call this diminishing marginal returns, which is kind of interesting that we actually see principles of economics, microeconomics in other classes. Pretty cool, at least for me. Okay, so that explains what this has right here. All right. Now, assume the company will purchase no more than 30 newspaper ads and no more than 15 television ads. All right. So what we want to do is now formulate a linear program model for this problem to maximize the number of new customers reached by the advertising. All right. So that gives us an insight into what our optimization and our objective function should be. All right. So let's set this up in a linear program. Okay. So here we go. Step 1. We need to define our variables. Okay. Well, I'm going to let x1 be the number of newspaper ads in the category 1 through 10. X2 is number of newspaper ads in the category 11 to 20. X3 is number of newspaper ads 21 to 30. All right, so if I have 15 newspaper ads, that means X1 will be 10 and X2 will be 5. Okay, I'm going to let X4 be the number of television ads 1 through 5. X5 is equal to the number of television ads 6 through 10. And X6 is number of television ads 11 through 15. Now the reason we set this up, again, our variables represent what is it we get to choose. So looking at our question, we don't get to choose the number of new customers. We don't get to choose our cost. All right. What we get to choose is how many ads we place in different mediums. And so that's what we want our variables to be. Okay. Now, step 2. What is our objective function? Well, it says we want to reach the maximum number of new customers. All right. Well, if that means if we put newspaper ads 1 through 10, so that's X1, for each of those ads, we'll get 900 new customers, because that is from this column here. So we're going to multiply X1 times 900, X2 times 700, X3 times 400, X4 times 10,000, and so on and so forth. So 900 X1 plus 700 X2 plus 400 X3 plus 10,000 X4 plus 7,500 X5 plus 5,000 X6. All right. Now, one thing to note is if we were to try to graph this out, because we have 6 variables, it's actually not able to graph out on a piece of paper. If we had 2 variables, we could. If we had 3 variables, we could probably do it in a 3D. 4 variables becomes now impossible. All right, so we just want to keep this out, that we're doing the same thing, we just can't do this actually graphically. So there's our objective function. Now let's think of our constraints. Okay, so what are the constraints that you see within there? Well, first constraint we think of as our budget constraint. Is there's a cost per ad that we have, but we only have $145,000. So the number of ads we put in newspapers 1 through 10 at $1,000 per ad, as we add all these up, they have to be less than or equal to 145,000. All right, so here we get 1,000 X1 plus 900 X2 plus 800 X3 plus 12,000 X4 plus 10,000 X5 plus 8,000 X6 has to be less than or equal to 145,000. That's our budget constraint. Okay, so put a little I here for the first constraint. What other constraint do we have? Well, one constraint it says is that we will purchase no more than 30 newspaper ads and no more than 15 television ads. So X1 plus X2 plus X3 is less than or equal to 30 Another way to write that in a little more mathematical notation is a summation of I to 3 xi is less than or equal to 30. Just try to blow your mind a little. The other constraint is that x4 plus x5 plus x6, the number of television ads, has to be less than or equal to 15. We can write it I equals 4 to 6 of xi less than or equal to 15. All right, so now we have those ads, but based on this, the question is, why wouldn't I just put 30 ads in x1? And that's because x1 is the number of ads 1 through 10. So we need to add an additional constraint here to take into account that x1 is only 1 through 10. So we'll say x1, comma, x2, comma, x3 has to be less than or equal to 10. We're going to say xi less than or equal to 10, where I is equal to 1, 2, 3. All right, the next one is x4, x5, x6 has to be less than or equal to 5. Each of those categories is 5. We're going to say that xi is less than or equal to 5 for I equals 4, 5, 6. And now we've set up our linear program. We've defined our variables, we've set up our objective function, and we've defined all the constraints.